3, question 3, part 2. So question 3, part 2. A particle is projected from a point in a horizontal plane with initial velocity of 70I and 105J. The magnitude and direction, we've done that, so we want to find the range, okay? So that's what we're looking for. So remember, it's 70I and 105. So it's 70I plus 105J meters per second. And basically, we're looking for the range. The range is the S, the distance in the X direction, max. That's what the range actually is. So if you're here and you fire something up at 105 and it goes this way at 70, they look about the same, but anyway, it will go up and like this. Okay, that's the projectile. Now, we want to know what is the distance here, S and the X, when it gets to here. It gets to here. What is that? This is a question mark. So that is, well, at this point, the time is the time of flight. That's the time to go all the way. And this point here is t a half, which is half the time. So the maximum height that reaches is actually, the time at which it reaches the maximum height is actually also half of the time it takes to go the whole way. Yeah, so time of halfway, right. So the time, twice the time to go halfway is equal to the time of flight. Yeah, so what I'm saying is the time to get to here is half of the time to get to here, because it takes twice as long to get to there. Okay, now, so if we could work out the time to get here, we could multiply it by 2 and we could work out the time to get to here. And if we knew the time to get to there, we know how long it takes, so we'd multiply that time by this velocity and work out the distance, or the distance to get to here, the range. Right, so up here, of course, what's special about up there is that the velocity is 0 at that point. So we can work out the time when the velocity is 0, then we can work out, then we know the time to halfway. Okay, so we start our usual U, V, A, S, and T. And these are all, of course, in the y direction. So even though I'm looking for the range, I'm using the quantities in the y direction because I want to find out the time it takes to get up there is half the time it takes to go this distance. Okay, so the initial velocity is 105. Final velocity to the top will be 0. Acceleration minus 9.8. Distance, don't know. Could actually work out the distance. Oh no, that would be the distance in the y. That would just give you the height. I don't need that. No point in finding that. But I do want to find this out because this is actually the time to go halfway, or the time to get to maximum height. So with U, V, A, and T, I would use V equals U plus AT to solve that. So V is 0 equals 105 minus 9.8 times T. That's the T a half. That's what I'm actually looking for. Okay, so that means minus 105 is equal to, if I take the minus 9.8 and divide it down here, I get T2 a half. And 105 divided by 9.8 is actually 10.7 seconds. So that is the time to halfway. So this time here equals 10.7 seconds. Okay, so that's the time to get halfway. So as we said, twice the time to get halfway equals that. So this obviously equals 2 times 10.7 equals 21.4. So 21.4 is the time of flight. So that's this time here. 21.4 is the time it'll take to get to here. So the distance x max actually equals velocity multiplied by time. So if it's traveling at 70 meters per second, and it does that for 21.4 seconds, that means that the distance max in the x direction equals, I work out 70 times 21.4 is 1,498 meters. That's the number I get for that. So that is the range.